Good morning, everyone. Welcome to this webinar on the multi-channel suite, our new software. My name is Carla Bellack and I'm the marketing manager here at Multi-Channel Systems. Before we get started, I wanted to point out two things. First of all, we are recording this webinar and we will send you the link to the recording during the next days. On the right-hand side, you see a Q&A window. Please make use of this window. Only myself can see your question, and I will read out the question to our speaker, and he will do his very best to answer them after his presentation. Today's speaker is Dr. Frank Hofmann. He's our application scientist for neuronal applications. He earned his PhD in biology at the University of Tübingen and joined our company in 2007. Today, he will give a presentation of about 30 minutes, and afterwards, as said before, he's available for the Q&A session. I will now hand over to Frank to get started.
Okay, welcome from my side too. So today's topic is the new multi-channel suite software. I suppose that most of you are already familiar with our former software, the MCREC software. So first, let's give you a brief overview of what you're going to hear in this presentation. I will talk about the multi-channel suite software, which is a software under development. Please keep that in mind. We are trying to improve it one by one, but we thought it would be better to give you a version that is not yet complete, but you can start working with it. We get some feedback what the customers actually want. But what you see at the moment is not, of course, the final stage of the software. It is supposed to be a general purpose software, not an application focused software like Cardio 2D or LTP Detector. So in the end, it's an alternative to MCREC. But so far, there are not as many features in it as in MCREC. But of course, the first goal for us would be to bring the multi-channel suite to the point where MCREC is now in terms of functionality, and then build up on what we already have. For that very purpose, we focused on bringing up the recording part of the software to operational state, and also the data export, so people would be able to record data with the multi-channel suite and export it to the analysis software of their choice. So the part which is the weak spot of the whole package at the moment is the analysis part. In contrast to MCREC, the multi-channel suite is divided into 3 software modules. They are independent. One is for recording, one is for offline analysis, and one is for data export. This one and that one, the export and the recording part, are relatively advanced, while the analysis is still lagging behind. An immediate benefit that you will have from using the multi-channel suite is the better AD resolution, because the MEA 2100 hardware is capable of a 24-bit data format instead of a 16-bit that you can record with the older systems. But so far we were limited to 16 bits also at the 2100, because MCREC can't really operate on 24-bit. So that would be an immediate benefit that you have when you're running the 2100 system. I think one of the major and obvious advantages of the new software of the multi-channel suite is that it has an easy drag and drop interface, which is more modern than MCREC is. And it is also free of charge, the same as MCREC. And the dongle, so to say, that we use, it runs only on our data acquisition devices. So the first part, the online analysis tool, is the multi-channel experimenter. It is for online recording. It currently supports the hardware MEA 2100 systems, the wireless systems, the old one and the new one, and also the USB-based older USB ME data acquisition system. So if you are having an older system with a USB data acquisition, you are able to use the multi-channel suite. This is a completely new feature, so it has not yet been released, but it's tested and it will be released the next days. The same as with MCREC, you open one instance of the software for each connected data acquisition system. Or if you have a MEA 2100 with, let's say, a 2x60 head stage with 2 MEAs, or if you have an ME system with multiple inputs and multiple connected amplifiers, you will get one independent software instance per MEA or per data input. So just the same as with MCREC, you can operate different data inputs independently. The data acquisition, so you will have many different virtual instruments, just the same as in MCREC, but they are a bit easier to connect and to operate. The data acquisition and the stimulator and the recorder can be opened only once, while all other instruments you can open multiple times. As I said, it's a simple drag and drop interface. We'll see it in a minute. And one very important and very nice feature, in my personal opinion, is that it is possible to program custom plugins, which then will show up here in the main software as your own special instrument. This can be a control interface for a device, for example, a pump, but it can also be a special analysis tool where the algorithm built in is up to you. You take the data from the core software, process it through your special algorithm, and the output has to have a certain format for the software to operate with it. But the idea that we are having at this point is that we have a developer toolkit where you get some sample code how to program such a custom device, and then you have to program it in a .NET compatible language, for example C#. And then you can, within that module, basically do whatever kind of analysis you like. And we hope that we will build sort of a community for people sharing their custom applications. That would be great. Okay, let's go to the next part, the multi-channel analyzer, which is the offline analysis package. This is the last developed part of the software so far. It is for offline analysis, of course. It supports files generated with a multi-channel experimenter. And one thing that is already added, which is quite nice, is that it supports a synchronized video input. It was mainly done for people who use the wireless system and do videos from the animals at the same time. And it is possible to synchronize the video input with the data input, and then also record events within the video, also within the data trace. And then while opening the software, you can opening a recorded file, you can jump back and forth within that file by using just simply clicking on that recorded events. We will see that in more detail later on. And also here are custom plugins available, or possible at least. The last but not the least important part of the whole package is the multi-channel data manager. The data manager is for data export, and it supports files generated with all MCS software. It supports the old MCREC format, MCD, and also, of course, the new multi-channel suite format, and also data generated with the CMOS system, with LTP director, with Cardio2D, whatever you have. You can use this data manager to export it with a single mouse click to HDF5 format, which is native to MATLAB. And this is a much quicker export than we're using the Neue-Share interface that many people use at the moment. And you can also export it to Python and other applications. I have to mention that Python, for example, in contrast to MATLAB, is for free. And you can also export it to Neuroshare, to Neural Explorer format, NEX, and also to Spike2 for people who like to use Spike2 for spike sorting, for example. And there's also a data compression included when you export to HDF5. So you simply define the grade of compression that you would like, and in the end up with very small files. So that was just a brief overview of the three different parts. Now let's go a bit into detail. First, we will see a quick video, how the drag and drop interface works. So when you open the software, the experimenter, you get over here all connected data acquisition devices. Here you see a USB ME256 and you see it 4 times for the 4 different inputs that you have in the front, and one MEA 2100 system. You see you have little icons here, so it's very easy to see which is what. And then you have a bunch of other instruments, and I will go through them one by one. But let's just see to begin with how this drag and drop interface works. For example, the first thing you do, you set your MEA 256 system either to linear or to MEA layout, and then you start. You just grab the data acquisition that you like, pull it over, then you look for the other instruments that you need, a recorder, for example, of course, and then maybe a spike detector and a filter. Now you have the instruments, and now you connect the instruments just by dragging lines between them. And these lines, they show you the flow of data. And whenever you click on one instrument, you get a corresponding control tab on the other side with the function and the control options for that specific instrument. You have the data acquisition, the filter, the spike detector, and the recorder. So you can see here, the outputs are color-coded, and only matching colors you will be able to connect. The recorder accepts all inputs, of course. But for example, a filter can only accept electrode raw data from the data acquisition system. It cannot work with the digital data, which is this output here. And here, for example, the filter data is still considered raw data, of course, and then it goes into the spike detector. And the spike detector output is either timestamps or spike cutouts, and this goes into the recorder. And everything that you connect to the recorder will also be recorded. So without having to click through different menus, you will immediately see, okay, what is connected here will also get recorded. So it's much easier not to forget recording a specific data stream. But you see here, the data output of the data acquisition system is directly connected to the recorder, so you will get a recording of the raw unfiltered data, and at the same time you will also record the spike cutouts and the spike timestamps. And if I would drag a line from here to there, I would also record the filtered raw data. Okay, but I will go through the instruments one by one. Let's start. I just wanted to mention that, of course, if you have multiple data acquisition systems connected, then you open multiple instances. I already told you that. And you will get a color code in each instance. The light blue one is the one that you're actually using. The dark blue ones are the ones that you could also use if you erase that one. And the gray one is the one which is used in a different instance. So here, these are not available in that instance. And the same goes here. This one is active over here, so it's gray over there. So it's pretty straightforward. You can't do any mistakes. You can't try to connect the same instance of the software to different data acquisition systems or vice versa. So come on, here you go. Let's try. Let's first see the experimenter for the USB ME systems, the older data acquisition systems. When you open the tab of the USB ME system, you see over here the well-known 8x8 MEA layout for the data channels. Here you have a drop-down menu where you select the layout of your MEA or a linear layout. Here you can set the sampling rate. If you use an ME system, you have to set the correct gain. When you press that button over here, will open a window where you set the gain with a list of different standard devices to show you what the gain should be. In the 2100 system and also the wireless systems, this is detected automatically. You can also record the hardware channels and the auxiliary analog channels. And when you hit the hardware info, you get also information about the serial number of your device, the ID, resolution, and stuff like this. Down here, you will have one channel zoomed in. We'll see some data traces later on. And the nice thing about this is that you can independently pause this zoomed in channel. So while your data acquisition is running and also maybe recording, you can pause this channel, zoom in on the data, and have a look at a specific signal while your experiment continues. Here we see how things look with the 2100 system. Most of the functions are exactly the same, of course. Here we have the data display of all channels, and here we have the zoomed in channel. And here we have now active the drop-down menu for the different MEA types. And you have, again, little icons showing you how the layout actually looks like. So it's pretty easy to navigate and pretty straightforward. We try to make everything as visual as possible. Now, this is how it looks like when you have a wireless 2100 system. It is also has its own icon. You set the sampling rate and so on. All this is just the same. But here you will also get all available head stages that are in range at the moment. And you can select one of these head stages, and then you will get also a battery power display. And again, you have this was a W4 head stage with 4 channels. And here you get the data channels and one zoomed in down here. So these are the most common data acquisition systems that you will connect. Now let's go through the other instruments. If you have a wireless 2100 system, or also soon to come a wireless 2100 system with internal stimulation, you will also get a stimulator. The external stimulators, the STG series, they are not detected by the multi-channel suite software. They still have to be operated independently, because implementing that control function also would be really a lot of work. We might do it in the future, but not at the moment. So here, for operating the stimulator, you have a display of your electrode field. You have 3 different stimulation lines. You click the simulation line that you want to use, and then simply click on the electrodes that you want to assign to that stimulation channel. You can start and stop independently one channel or all of them. And over here you define your stimulation pulse. You simply take one of these so-called primitives, so these standard waveforms, and drag them down here to generate the complete pulse. Can be as many modules or primitives as you like. You can set up things like increasing amplitudes or increasing frequencies. And down here you get an overlay of the 3 different stimulators. In blue you have a rectangular pulse, in green you have a sine wave, and in red you have ramps. Those guys here. And they can either be started independently or all together. Each individual stimulator can react on a specific start and stop signal, which is either a manual mouse click or incoming trigger or an internal trigger event, whatever you prefer. Of course, the STG or the internal stimulators also produce triggers, which are recognized in the software. We will come to that in a minute. So, the next instrument to come is the digital event detector. The digital event detector needs to be connected to the digital output of the data acquisition system. You see that here. Again, the color matching in and output. And you see down here that I have relatively easy overview of what I can choose as an input for the digital event detector. I have the 4 physical digital inputs, which are located on the interface board of the MEA 2100 system, for example. And here I have the 3 internal stimulation lines, green, blue, and red. And I can select the digital event detector to react on an input of any of them or all of them in combination. And over here has little blue dots, and also if I want as a audio beep, I get a marker for each incoming trigger. I can combine, of course, different channels, so I can say that whenever the stimulator is active and a digital in comes from the outside, then this is a trigger event, or I can have individual triggers for both of them. The digital event detector produces as an output a trigger event. We will need that later on. So the next instrument I want to talk about is the filter. The filter needs raw data as an input, of course, and produces filtered raw data just the same. So these colors are the same. You see here, you select the filter characteristics, the type, high pass or low pass or notch, the order of the filter and the cutoff frequency. And over here in the data display, you get the raw data and the filter data in overlay. So what you see here is the filter data. So just that you see it, I filtered at with a low pass filter of 200 Hertz. So mostly all of the high frequency components are filtered away. Next comes the sweeps tool. The sweeps tool is meant to produce data fragments around a certain event, usually stimulation. So the sweeps tool needs as an input, of course, the raw data from the data position, but it also needs a trigger to work on. And that trigger can come from any event that produces trigger, the digital event detector, but I will also show you a different tool that also produces triggers. So at the moment here, we have the data source connected to the sweeps tool for the raw data, the digital data coming from the data acquisition system going to the digital event detector, which detects that inside that digital data, the event that you want to look at, produces a trigger, and the trigger also goes to the sweeps tool. The sweeps tool has the same data display as all the others. However, it doesn't show you continuous raw data, but it will show you a fragment around your trigger event, starting and lasting for as long as you like, a few milliseconds usually. And down here you see in the zoom channel, the trigger was a stimulation event, which happened at time point 0, so here, and you can see the small blanking period where all the electrodes were deactivated to avoid stimulation artifact, and this little residual artifact here when the recording electrodes come back online, just something short of 2 milliseconds after the actual stimulation. So that would be the standard tool if you work with evoked activity. Then as an output, you get these sweeps, which can also then in the end be connected to the recorder. Okay, another instrument that can also produce trigger events, and that is some nice improvement in contrast to MCREC. So far we have seen stuff that MCREC can do just the same. Now we see something new that we would have liked MCREC to do for a long time. However, the basic structure of the software prevented us from doing so, but now we can do it. In contrast to MCREC, the multi-channel suite has a standby mode. So it can go in recording standby, wait for a trigger event, and then either record until another trigger event happens or record for a certain period of time. That was something that was simply impossible to do with MCREC. And many people asked us for that over the years. So we implemented that as one of the first really new tools in the multi-channel suite. So what you have here is a trigger generator. You can generate triggers either in a periodic fashion, so one trigger every second, every hour, every minute, every millisecond, doesn't matter. You can set up a completely random list where you type in a time in hours, minutes, seconds, and milliseconds, and thereby generate a random list of trigger events over time. Or you can simply hit a button and produce a manual trigger event. You can also have more than one of those. For example, one trigger generator who generates you a periodic trigger to start your recording, and you can have another trigger generator that you use for manual generating triggers to mark certain events within your recording, for example, adding a substance or something. The output of the trigger generator is, of course, a trigger event, and then that trigger event can, for example, trigger a sweep, or it can simply trigger your recording. A standard thing to do would be, for example, to set up an automatic recording regime with that trigger generator to do, for example, 5 minutes of recording after 5 minutes, 10 minutes, 15 minutes, 1 hour, 2 hour, 3 hour, 6 hour, 12 hour, 24, 48 hours. This would all run completely without manual control. Next up is the spike detector. the spike detector can work either on raw data, or of course also on filtered data. It works just the same as with MCREC. It detects spikes either by threshold crossing or by slope. You set the detection level automatically with a manifold of the standard deviation of the noise. The standard deviation of the noise is calculated whenever you hit that button here, multiplied with that factor that you find here, and then you get an individual threshold for each electrode, and either every signal crossing that threshold will be detected as an event, or if you use the slope method, which I didn't describe here in detail, you get a combination of the slope of the signal and amplitude of the signal. Whatever it is, in the end, as an output, you have either timestamps or spike cutouts. Spike cutouts are short data fragments, which size you define here, usually a few milliseconds around the detected event. Or if you're only interested in just the timestamp of threshold crossing, you can have a timestamp parameter. This can, of course, also then in the end be connected to the recorder. Next, and finally, we have the recorder. And you see here in that rack over here, you see that many data streams finally come down to the recorder. We have the raw data going through the filter, going to the spike detector. There we have the timestamps and the cutouts. We have the raw data unfiltered and without anything going into the recorder. We have a trigger coming from the trigger generator, and we have a trigger coming from the digital event detector, all converging to the recorder. In the recorder, you can set the file name, of course. The same as with MCREC, no file will ever be overwritten. So if the file that you've specified, the file name that you specified already exists in that very same folder, you will automatically get a second file number, then your file name 001, 002, and so on. But you can also set an automatic prefix, an automatic suffix. And down here, you now have the start and the stop options for the recording. The start options can either be a manual mouse click, a certain event, or it can be a timer. The same goes for stop. And with this function, you can produce what I've just described to you. Whenever I get a trigger event from the trigger generator, start a timed recording of, let's say, 5 minutes or whatever it is. And down here, you get a simple list of the recorded data streams. So everything that's connected here, you get as a data stream, and you get the instrument it originates from. Something that I forgot to mention is that, of course, you can also rename those instruments simply by double-clicking them and giving them any name, and these names then will also show up here. And once you designed such a rack, it was called an MCREC, now it is called an experiment. You can save those experiments, and you can also load those experiments again, so you don't have to go through the whole procedure again. It's pretty straightforward and just the same as with MCREC. And also the general control of data acquisition and recording is very similar. You start data acquisition without recording with this button. When you hit that recording, the software goes into standby mode and then waits for the start command for the recording, which is either starting the data acquisition or some certain trigger. And usually whenever, if the data acquisition is still running and the recording period is at end, it simply goes back to standby mode and waits for the next event to come. So that was the online recording tool, the most advanced part of the software, I would say, so far. The multi-channel analyzer is the offline data analysis part, which I said that before is, so to say, the weak spot at the moment. It doesn't have that many functions so far, but one is very interesting, and I will come to that in a second. Namely, so the basic idea is you have a Spike Explorer or a Raw Data Explorer. There will be other Explorer tools added. Just drag it over. This is to look at raw data files. This is to look at spike cutout files. And then just the same, you can set up a tree of instruments and look at your data. And the idea is that you don't need to look at all the data while analyzing. The idea is that you open the Raw Data Explorer, look at a segment of data, adjust your settings, for example, the filter settings and the spike detection settings, and then you hit that Start Analysis button, and the whole data file will be pushed through that queue here, and in the end, that is still missing, you get sort of a result output. The advantage of this, in contrast to MCREG, where you had to actually replay the data, really look at the data while the analysis was done, is that it's much faster. So if you're doing a rather complicated analysis with many channels, and if you want to run it through a file that was recorded within 1 hour, for example, just running through that file would take maybe 20 minutes at least with MCREG if the analysis is complicated. However, if you just look at a fragment of the data and then automatically punch it through that analysis queue here, it will be done within seconds. And this is still missing. In the end, you will get a result of whatever kind of analysis you did. What is very nice that you can navigate inside the data file much easier. You have that slider here. You get one channel representation of the complete recording. So that was the complete recording period. And you have that slider and can just go back and forth in the file, and you will see the data fragment up here. Again, all channels, one channel zoomed in. You can jump back and forth with this little arrows here, or use the slider. And also down here, you see detected digital events or other trigger events, and you can simply click on that digital event, and you will immediately jump to the corresponding data trace. And now if I hook up this to the so-called video player, the video player can accept all kinds of Windows-compatible video files. We can also synchronize your recorded data with the video data. The very last that we need to do so is 1 TTL at the beginning of the video and 1 TTL at the end, and a reasonably stable frame rate. Then we can synchronize the electrophysiological and the video data. What is even if you have a constant timestamp within the video file, or the recorded electrophysiological data, then the synchronization is better. However, the question is how precise does it need to be when you just want to know what happens when the animal presses a certain lever. That's pretty easy to do, because then the synchronization doesn't need to be much more precise than, let's say, a millisecond or two, which is easy. However, if you go down to the microsecond range, things become a bit more tricky. But let's say the necessities of the camera are quite low to be able to synchronize the eFuse and the video data. So here you see what it looks like. If I open the tab of the video player, I get my video. And when I hit the sync data button, I go from that very frame that I'm looking here at the moment to the corresponding video data. And the same is possible from that side to the other. I go to a certain point within my video file, hit within my electrophysiological data, and hit the to video button, and immediately the video tool will jump to that specific frame. As I said, the better the timestamping of the video is, the better also that synchronization can be. Last but not least, the multi-channel data manager. The data manager, I told you that already, is not only for multi-channel suite data, but for all data formats that MCREG and all our other software applications are using. And it can do a one-click export to a bunch of different software applications. Usually, the most common software format is HDF5, which is used by MATLAB as well as Python. And we can also do Neural Explorer at the moment in Spike 2. What is in the making is European data format, which we found is used by many labs doing EEG recordings and sleep research, and there are existing tool packages which need that format. So I think this is one of the next which will be added. And of course, this is also a project under development. So anything that you would like to have, and if a reasonable number of people think the same, then it will be added sooner or later also to the data manager. And it is very, very fast. So here you open a certain folder, then you get all files that are compatible with the software. You get the layout, you get the different the different streams within that software, start and stop time, recording date, and so on, what the device was that was used to produce that. And you simply select the file or the files and the streams within that file that you want to export and hit the export button that you want to use. You will get that little window here while the file is processing, which takes not longer than a few seconds, and you're done. And that is very easy and much faster than the interfaces which were used so far. There's also a compression built in, which goes for HDF5 format, which can make very large files much smaller, which is also nice. So that's it, basically. I'm sure there are some questions which I will be happy to answer. Thank you for your attention.
Yeah, thank you. Thank you, Frank. Actually, we already had some questions. First of all, with which operating systems does the software work?
Only the latest, unfortunately. So Windows 8 is mandatory. This for the simple reason that it is a much more effort to keep it compatible also with older systems, and older operating systems will have to go sooner or later anyway. So we thought it makes more sense to focus our resources on building something new for a new operating system than wasting them by trying to make it compatible with older operating systems.
Okay. Another question was whether it is possible to load old MCREC files into the analyzer.
Unfortunately not, no, because the data format is completely different. As I said, you can export both the old and the new format to another application, but you cannot load MCD files into the analyzer.
Okay. Another question is if MCREC will still be supported.
Yes, insofar that we will, of course, fix bugs, but we will not put in more features. And we will not add additional features any longer, because we really decided to focus our resources on the multi-channel suite for the very reason that MCREC is simply outdated by its in terms of software. It's really old age, very old age. It's more than 15 years old, and nowadays things can be done much easier, much better. And yeah, we just have to focus the resources that we have, and we suggested we try to focus them on improving the multi-channel suite now. Of course, MCREC will be supported and kept operational, but no new features will be added.
Okay. We had another question about the availability of the software.
It is already free to download from the website, all three packages. There will be a new release within the next days where you can also operate the ME data acquisition systems. Just have a look at the website under download software, and there you will find it. Free to use for anybody.
Actually, if I'm from the marketing department, we will also send out a newsletter probably next week with a new release. So you won't miss it if you're assigned to our newsletter. Another question was again for the operating system. So it won't run on Windows 7.
Maybe it will, but we don't guarantee that it runs. You may have a try. But as I said, it's just for us, it's too much effort to keep it compatible with all older operating systems. And I mean, Windows 10 is up, so we'll be there within the next few months probably. So we'll be busy keeping up with the new operating systems. Just there's no way that we can also support the older ones. Sorry.
Okay. This was it for questions so far. So thank you everyone for attending today's webinar, and thank you, Frank, for presenting.
My pleasure.
Well, if your question has not been answered, we will send you an email, and you will also get an email from us with the recording in case you want to listen to it again. We have upcoming webinars on the MEA systems and wireless systems in May. You see the dates here below. And as always, if you have any question, please just give us a call or drop us an email. We will stay online for about another 5 minutes, so in case rethinking the webinar, you come up with more questions, please feel free to use the Q&A window again. Thank you for joining us today and have a good day.
Bye-bye.
Bye.